In this video, I'm turning this pile of boxes into this CNC router. CNC machine? That's not real woodworking. Ugh, can't unsubscribe fast enough. There appears to be two camps to CNC machines in the woodworking community. In Camp 1, there's the purists, the ones who cherish their hand planes and dovetail saws. If you didn't shape every fiber of that board with your hands, well then you ain't a real woodworker. Then there's Camp 2. This camp embraces modern technology, awes at the engineering and precision modern machines are capable of, and uses their strong suits to their advantage. Each camp no doubt requires a different set of skills and knowledge. There's no reason to fear technology in the workshop. I personally love technology and what it can do for you, especially in the home workshop. CNC machines have come a long way in the last 10 years, and they are now affordable enough for the small workshop to obtain. It's amazing what's available for the home workshop these days. In my short time using CNC machines, I've learned that there's a whole world of knowledge and skill that I'm looking forward to learning. This technology is not for everyone, but I freaking love it. It's worth noting that this is not a sponsored video. A lot of CNC machines on YouTube are sponsored. About 3 years ago, I made a goal to buy a CNC router solely from the money I can make doing woodworking videos online. For the last 3 years, I've been putting that money aside from the money I've made doing the woodworking videos and put it into purchasing this tool. Thanks to everyone who's watched my videos or purchased plans from my website, as you've helped me to achieve my goal. I'm super excited about what I'm going to learn and what the future of this CNC machine has in store. If you want details on this particular CNC machine, I'll leave a link down in the description. In short, I chose this machine because of a few factors. I liked the aluminum construction, the linear bearings, and overall robustness of the machine. One of the main reasons I liked it was because of its form factor. Most small machines don't have their long axis on the x-axis or the left to right axis. This allows it to fit really well in my small shop. Alright, things are going well. It's starting to look like a CNC machine. I've got pretty much all the mechanicals put together, so the base is put together, the gantry is put together, and I've got the drag chains in place ready to run the wires, and that's the next step, is to run all the cables to all the motors and the sensors. It's the next day, and I got all of the wiring done. I mounted one of the control boxes up on the wall and one of them on the bottom of the machine. So now we can move on to the little more exciting part, which is mounting up this monster of a spindle motor. Alright, I got the software installed and it's plugged in and I think we're ready to go. How do I make the Z go up and down? So cool. Oh. Woo! Yes! I'm excited. Now that I got the machine running and it's square and it's level, I can go ahead and make my first part, which is going to be a spoil board for the top of the machine. Now there's all kinds of designs out there for spoil boards. There's ones with T-tracks, there's ones with dog holes and vacuum clamping. There's a whole host of designs, but I don't really know what's going to work for me best yet, so I'm just going to take the simplest approach to start, which is just going to be a 3/4 inch sheet of plywood down first and attached to the rails, and then on top of that plywood I'll put a sheet of MDF to act as the actual sacrificial portion of the spoil board. And for now I'm just going to screw parts right into that. And further down the road, after I get an idea of what I'm going to want, I'll redesign the spoil board to include long-term work holding options. I've already made a 3D model of the spoil board on the computer, and I'm going to use the CNC router to cut out the holes for the fasteners that are going to hold it down to the aluminum extrusions. I made these spacers off camera, and it gave me a chance to practice these holes I'm going to make in the spoil board. Since this is the first G-code file I've ever made, I was able to test it out to make sure it worked, and I can also use these test pieces as spacers to keep my spoil board up off of the aluminum. I'm just going to hold this plywood down with some screws, and I'll put the screws where I know I'm not going to be drilling with the router. The beauty of making these on the CNC router is that they are slotted, and that allows the whole board to be shifted front to back, and that allows me to get this nice and flush with that front rail. For the actual spoil board, I'm going to use this piece of 1/2 inch MDF. And since my plan is to screw down into the spoil board to hold parts on anyway, I'm just going to screw it down instead of using clamps. As soon as the glue dries, I'll be able to flatten it, and that'll make sure the bed is perfectly parallel to the rails. And to do that, I've got this large flattening bit, and as you can tell, this is going to make quite the mess. And so what I need to do next is hook the dust collection up first, so that I won't make a giant MDF dust cloud in here. You just saw me print the 3 parts for the dust boot, but I actually printed a whole bunch of fun things. May have gone overboard. I've got the 3 parts for the dust boot here, which I'll assemble in a bit, but I've got the bottom part, which will have brushes. It'll have magnets that attach it to the center part. The center part is clamped onto the spindle, and then of course I've got the port for the 4-inch dust hose, which will screw on there. I also printed a holder for the touch plate and edge finder, and that just slips in like that, and I can attach this to the side of the machine. I also 3D printed a holder for the grease gun, and that'll just be a nice holder for the grease gun so that it's always on the machine and has a home. And this is for greasing the linear bearings. And then I printed all of these parts to add LEDs to the machine because everything is better with LEDs. And I've got a strip of LEDs here that I'm going to attach to the underside of the gantry. And these holders are going to snap into the extrusion and hold the LED strip and keep it attached to the machine. And then I printed off this holder for a switch, which is going to turn the lights on and off. Sweet. The two halves of the dust boot are held together with magnets, and I used these rare earth magnets. When I 3D modeled the dust boot, I made the holes for the magnets slightly undersized so that they would be a press fit. That way they don't need to be glued in place. I use my small vise to make sure that the magnets are pressed in and flush with the top surface. I didn't know how many magnets to use, and as you'll see at the end of the clip, I think I went a little overboard. The 3D printed parts actually had a slight bow to them, and I thought I was going to have to reprint them. But the magnets actually pulled the bow out of the parts and snapped the parts together nice and tight. It's incredibly strong. Holy crap. In addition to the magnets, I also modeled in hexagonal holes where I could press in these number 10 nuts right into the 3D printed part. And this works a lot better than just screwing right into the plastic. I was really struggling to get these brushes to go into my 3D printed holder. They would just be splaying all over the place and popping out. And then my wife came out to the shop and she put it together in one shot, like it was no problem. So I had her help and put this together for me. Now that I've got the flex hose attached, I can tell that I need one more bracket here. This flex hose just wants to flop over on the gantry. And so I think I need to add a bracket to hold up the flex hose right here and attach it to the top of the Z-axis. And that should keep it up out of the gantry. And if I pin this up to the ceiling, that should keep it up and out of the way. And that should organize this hose a little bit better. So back to the 3D printer. Hope you are enjoying these 3D printed time lapses in this video. I went down a whole rabbit hole just to figure out how to do these for this video. I printed two more parts for this hose holder. This one's by far my favorite. So this has a hole here that's going to hold on to this coupler, and this coupler just slides in to that hole, and I can clamp a hose on either side of it, and that's going to keep the hose from falling through this hose holder. And then this is going to bolt onto, there's two spare holes here on the Z-axis, and they are already threaded, and I've incorporated a notch here on the back of this bracket that's going to fit around this steel plate. And with the two screws, or the two bolts, I can attach this hose bracket right to the Z-axis. My new hose connections look pretty good, and I've got it pinned to the ceiling for now. and I've already got the flattening bit installed in the router, and so I am ready to finally flatten this spoil board. Well, that went extremely well considering how nerve-wracking it was for my first time. The board feels perfectly flat. I don't see any ridging. You can see some little variation from the passes, but I cannot feel any difference in steps, and so that means the router is pretty square to the bed. There is a little bit of dust left on the surface, and you can see a little bit of the dust that was left on the rails, but for cutting MDF, I'd say that did a pretty good job. I actually did have my air quality meter going the whole time, and the air values for the particles have not really changed since before I started flattening and after, so that's a good sign that it sucked up at least all of the fine stuff, so pretty happy with how it's working for now. This is an exciting part in the project because now that I've got the top flattened and the dust collection hooked up, that means I'm pretty much ready to start cranking out parts on the CNC machine. The first thing I'm going to make is the front vertical spoil board that's going to attach to the front here and allow me to do machining on the ends of boards. And then after that, I want to cut out a few parts that I'm looking forward to and give you an idea of what I'm going to use the CNC machine for in the future. Unlike the top spoil board, where I'm not really sure yet what I need for clamping, I do know how I plan on using the vertical spoil board, and I came up with a design for it to start with. The vertical spoil board really only has a couple of uses. I'll either be cutting joinery on the ends of boards, like on table legs or shelf brackets, or drilling in dowel holes or loose tenons on larger sheet material. I looked up online at other people's spoil board designs, and I ended up doing something similar to what Jay Bates did on his CNC. I'll be sure to post a link to his video in the description. My design uses several rows of 3/8" dowel holes for positioning boards perfectly vertical, and even at angles for making tapered joinery. In addition, I put several cutouts in the spoil board for putting clamps through it for holding down the parts. To hold the spoil board to the machine, it uses the same slotted holes as the top spoil board, and it attaches directly to the aluminum framework. Here you can see I've clamped a board to the front spoil board, and I've used the tool dowel pins in the center holes to locate it perfectly up and down. And then I can also do it at an angle, like I'm showing here, by just moving one of the dowel pins to one of the other holes in 5-degree increments. I'm finally ready to make my first part that is not for the CNC machine, and for that I've got this cutting board blank here, and I'm going to use the CNC machine to put a juice groove on both sides, and then I'm going to mount the cutting board to the front spoil board and put handles and also do a small engraving on the sides of the board. And that should give a good representation of how I can use my different spoil boards and the CNC machine to make some cool parts. I've already got a bullnose router bit put in here for the juice groove, So let's get started. I ended up finishing this cutting board by filling the engraving with black epoxy and applying a coating of mineral oil and beeswax, and it came out great. Now, cutting boards are pretty cool, but what's even cooler than that is my overarm dust collector for my table saw. If you haven't seen this before, you should go check out my video where I built this. This is one of those projects where, now that I have it, I don't know how I could live without it. It does such a good job at collecting the dust that comes up off the top of the blade, especially on things like MDF. It keeps the workshop much cleaner, and I can see the results on my air quality monitor. Like I mentioned before, I do sell plans for this on my website, but I've had people reach out to me and ask for either CNC cut templates or actual CNC parts of the dust hood, since it is kind of curvy and a little bit difficult to cut out. When I was getting the CNC machine, this is one of those projects where I thought it would be a perfect first thing to try out on the machine. For these templates, I'm just using more of the 1/2" MDF, the same stuff I used for the spoil boards. And I think that makes for a nice beefy router template that could be used several times if you wanted to make a couple of these dust hoods yourself.